Hey everyone, welcome to Homework 6.1. Today we looked at categorical data, which is data where values are categories. So, for example, the breeds of 10 different dogs are categorical data. They're not numbers, right? They're not numerical data. They are word answers. Non-statistical question is a question in which it can be answered by a specific measurement or procedure, and there's no variability, right? There's one answer. How high is that building? It's 100 feet, right? If I run it 2 meters per second, how long, right? We get one answer. So it's non-variable data, right? That data is going to stay the same. Numerical data is data that is measured with quantitative data, numbers, right? They're numbers, measurements, quantities. Weight, for example, we're going to get a number as an answer. And then a statistical question is a question in which we will get a variety of answers. So we should expect that we're going to get not all the same answer and that there might be multiple possibilities. So down below, you are to write 2 survey questions that you would expect to collect numerical data. You need to come with those questions for tomorrow because you're going to share them with your group. And then 2 survey questions for which you would expect to collect categorical data. And then for question 3 and question 4, you are just answering these questions. Again, I'm not going to go over these because I think that you all can answer them. So the CAPE-related question we're going to look at together. And so I gave you a hint here. Remember that averages are values added and divided by the number of values. So that's the average. Note that the other word that we use to describe average in mathematical terms is mean. The mean is the average of values. So it says the height in inches of 3 boys is 54, 48.5, and 46. The height of a 4th boy is denoted by h inches. So h is the boy that we don't know. And these are the values of the other 3 boys. It says the average height can be represented by this function, where c and d are constants, meaning they are numbers. What are the values of c and d? So if we are adding up all the heights of the boys' heights and then dividing by the number, we have 4 boys, right? So we would divide by 4. So 4 is going to go there. Now C, remember H is the height of the 4th boy that we don't know. But C then would have to be the heights of all the other boys. So we would add 54 plus 48.5 plus 46. And you can use your calculator or your brain. It doesn't really matter here. 18, carry the 1, 14. And so this might be an example where you would see, like this is totally feasible to do in your head without a calculator. So this could be a question on the non-calculator section because all you're doing is filling in those blanks and adding some pretty simple numbers there. Okay, all right, so that's what that would be. And then it says select an option from the drop-down menu. So the appropriate domain for function A. Domain means the appropriate inputs. Remember, the input that we're talking about is the value of the 4th boy's height, right? So remember, domain is inputs, and the input here is the 4th boy's height. And so would it be the set of all real numbers, the set of positive real numbers, the set of all integers, or the set of positive integers? Okay, so integers are whole numbers, 1, 2, 3, 4, 5, 6. And we can't have a negative height, right? So it can't be all for either of these. It would have to be positive real numbers or positive integers. Well, heights can be with decimals, right? We have examples of decimals here with 48.5. So this would be the set of positive real numbers. Could be any positive. Now, realistically, it wouldn't be more than a certain amount, but it's the set of positive real numbers. And then it says the function is decreasing in linear, decreasing in nonlinear, increasing in linear, increasing in nonlinear. All right, well, this is an average, right? Which means that this is not going to be, oh goodness, sorry, showing my emails. This is not going to be an exponential function or a quadratic function, right? Because it's something that has a constant value that we'll get. And so in this case, we're adding his height, and as his height would increase, right? So if his height goes up, then the output is going to increase as well, right? The taller this boy is, the higher the average will be. So this is increasing and linear. All right. If you were to graph this, you would end up with a value, a number, right? And so it's going to be increasing and it will be constant linear. All right, the data related question number 2 is asking you about a tomato garden. So Bella has this tomato garden, she's planting seeds, and then she's showing you your first year, second year, the number of seeds planted, and then the number of tomatoes harvested, and then it wants you to justify the third year. So she says that the third year is 3,240, and it's asking you whether you agree or disagree, and you need to give a reason why. So I'm going to look at this as a ratio. If I plant 75 seeds, then the number of plants that I'm getting is 2,000, or the number of tomatoes I'm getting is 2,025. So that means for every seed that I plant, I'm going to do 2025 divided by 75. So for every seed, I get 27 tomatoes out of that seed, right? Because I would multiply 75 by 27, so you get 2025. Let's see for 20. Let's see if there's a pattern here. So 540 divided by 20 is also 27. It means I'm multiplying by 27. So 3240 divided by 120 is also 27. So here I'm going to say I agree with her. I'm going to type this out just for ease because it's a lot to write here. All right. So I agree with Bella because for every seed she planted in the first year, she harvested 27 tomatoes. And in the second year, we see the same output. Let's revise that a little bit. In the second year, we see the same output of 27 tomatoes per seed planted. This means that if we planted 120 seeds at the same rate of 27 tomatoes per seed, we would get 3,240 tomatoes. All right. And then you can also show your math in this type of question, right? So you can show 120 times 27 equals 3240 as such, okay? All right, so the first part is pretty simple. Let's take a look at part B. In part B, we're looking at a breakdown of months, right? And how many they're harvesting each month over the summer. And it gives us that she harvests 3240 during the third year, as we saw above. Right, so that's the total amount for the third year. And so what we want to do is compare, is provide justification for your number. So there's actually a couple of ways that you could justify this, and there's actually variability in what you could produce for the third year's numbers. The key thing is it has to add up to 3,240 tomatoes harvested, right? It has to add up to equal this. But one way to look at it is how many tomato plants they harvested each month in comparison with the total. So if we look at 243, and actually let me just open like a regular old calculator here so you can see. So if we were to look at 243 plants divided by 2025, this gives us the percent of tomatoes harvested in July out of the total, right? So that's about 12% of the tomatoes that we would get that year. And so then let's look at 685 divided by 2025 gives us about 34%. And remember, we want this to equal 100%. So we're assuming that that last bit there, that 1097, oops, 1097 divided by 2025 gives us about 54, and that will add up to 100. because then we have 56% or 46% plus 54 is 100%. All right, so approximately these percentages. Let's look at the second year and see what we get there. So in the second year, we have 97 divided by 540, which is going to give us 18%. So that was a little bit more for the second year. Let's see, 191 divided by 540 is 35%. So that's pretty similar for our August tomato harvest. And then if we're going to do the last one, 252 divided by 540, that does look to be about, 47%-ish. Okay, so for you to calculate out of 3,240, then we can estimate using these percentages, right? So between 12 and 18% is what we would expect to get in July for the third year. So let's say, let's just average that. So 12 plus 18 is going to give us 30 divided by 2. Sorry, is 15. So let's say it's 15%. So 0.15 times 32, 0.15 times 3240 is 72.9. So we'll round up. We'll say 73 tomato plants in July for that one. And then if we were to say, this is pretty close, right? 35%. So let's go ahead. We'll do, let's do the lower amount. We'll do 34%. So 0.34 times 3240. And that would give us 1,101. All right, so now we have 1,101 plus 73 is 1,174. And so we need a difference between 3240 and that, right? So 3240 minus, what's it? Did I add that correctly? I don't know if I add that correctly. Let me see. 73 plus 1. Oh yeah, 1174. 1174. So 3240 minus 1174. It's 2066. Let's see. Well, I'm going to write it down so I don't forget. But 2066 divided by 3240 is about 64%. So it's a little bit high, maybe. But the key is that it needs to add up to equal 3240, right? So we need to have all of our amounts equaling that amount. So 0.15, let me make sure. Oh, I was like, something's wrong here. Okay. I don't know what I did earlier. Let's go back and erase this. I'm sure exactly what. I think I calculated something wrong. So if I said 15%, right, is what I estimated that to be, out of 3240 is 486. I think I did it out of 120 or something. Okay, so then this number should be a lot smaller. All right, so 486 plus 1101 is 1587. And so if we have 3240 minus 1587, that's 1653. Okay, that looks a lot better. 1653 divided by 3240 gives me 51%, and that looks nice in between 54 and 47%. Okay, so for this one, the key thing is that you have to be able to justify it, right? Because actually in the PARCC rubric, they actually give us ranges that they would count and include that would be giving you full points, right? So the most important thing is that you can explain how you got your numbers, right? So you can say, first, I needed to make sure that all of the months added up to 3,240 tomatoes. I calculated the percent of tomatoes harvested in each month out of the total harvest. it was 12% for the first year and about 18% for the second year. So I estimated that for the third year, it would be about 15% of the total harvest, which is 486 tomatoes. Right? So you're explaining out how you got your numbers, all right? And looking at the percent of tomatoes that were harvested per month out of the number that was the total. So the key thing here, again, is that you need to provide justification for your numbers. I'm going to show you the rubric so you can see what I mean. So this is the rubric that they use to score this. And notice that this is out of 2 points. So you need to have correct computation, meaning you like calculated things correctly. And the modeling component means you explained, right? You have correct justification, so you explained adequately. So here, I started by looking at the first month, right? July, August, and September. The sample student response starts with comparing September. That's fine. You can start with any month. It doesn't matter. We ended up getting, I think, about 51% in September. And so they're estimating in the first year it was 54% of tomatoes, and in the second year it was 46%. So it seems reasonable that the number harvested in September for the third year would be about 50%. And so then they estimated, right? And they explained it. That was the key point, that the numbers add up to 3240 and that the rationale is accurate and reasonable. So notice there's acceptable ranges for the monthly tomato harvest. There isn't like an exact answer. They said for July, anywhere from 380 to 600 would be acceptable. Anywhere from 950 to 1200 for August and 1500 to 1800 for September. So going back to ours, right, we have 486 for the first one. That's between that range. We have 1101. That's also in this range, and September is 1653, which is right in the middle of this range as well. So for a question like this, because the percentages are different in the first and second year, your answers for the third year might vary depending on how you interpreted this data. But again, the key point here is that you had to justify your answer and explain how you got these numbers and that your calculations are accurate. Okay? All right. Your code word for today is heirloom. Heirloom is a type of tomato, okay? Heirloom tomatoes. So heirloom is your code word for today. I'm now going to create a separate video that's going to go over the first and second questions of that park released items that you have in your packet.